All right, half of it will be missing, but that's all right. So if I have this battery, 18 volts, and I have these wires, these parallel wires, like that. What I mentioned to you in class was if I take a voltmeter and I put it here, across here, then I measure the 18 volts. If I walk over here, the wires just act as extensions to the battery. So I get 18 volts here, I get 18 volts all the way down to the end of these wires. So what that means is if I put those two resistors between those parallel lines, I put the 6 ohm right here, and I'll put the 3 ohm over here. Then that 18 volts is across both those resistors. So what we said for parallel circuits, parallel circuit will have the same voltage across every component, but what's different is I'll have many currents. I get the main current or the main line current coming from the battery. When that current gets to this point, it's going to split up. And in the series circuit, where the voltage is added up, here in the parallel circuit, we'll get the currents adding up. But let me put those on the board, the rules that we came up for parallel circuits. Now, there was a couple for resistance, a couple formulas for resistance. The main one I call the 1 over R rule. So 1 over RT equals 1 over R1 plus 1 over R2, and I can just keep doing that. If we have two resistors like I have here, it's convenient to use the product over the sum rule, so I can get the total resistance as R1 times R2 over R1 plus R2. And then if the resistors are the same, I gave you a special case formula, which I won't put that up here because I think we've already done that. But what we can do here basically is easily find each current. Now each connection between the two parallel wires, each connection is called a branch. So the current in a branch is called the branch current. And what we said in class when we talked about this is my total current is going to leave the battery. That's IT. And then it's going to branch off when it hits this point right here. I'll get some that drops down through here. If this was R1, I would name that current I1. You name the branch current after the branch resistance if there's only one resistor in the branch. So I'm going to name this one I2. Then I can find each of these currents pretty easy by just taking, when I want to find current, remember current is just voltage over resistance. So I can do that for each branch. So if I take the voltage, the 18 volts, divided by the 6 ohms, I'll get for this 3 amps. So what I'm going to do is put a box around here, indicating that that's an ammeter. I'll do the same here. If I take the 18 volts across this resistor, divided by the 3 ohms here, I'll get 6 amps. Again, I'll put my box around my ammeter. And then I can use these two because we know Kirchhoff's current law says that these branch currents should add up. If I write that down for you, you should already have that in your notes somewhere. Kirchhoff's current law says that the total current is equal to the sum of the branch currents. So I can just keep adding those up like this. So if I add these up, I get 9, and I have 9 over here for my total. And I see that it adds up. Now this is pretty simple, but it's important because what happens is, this is pretty easy to do. A series is pretty easy to do. But what happens is when we put this together, sometimes it's a little hard to see what's in series with what and what's in parallel with what. And I'll show you an example of that, if not today, then on Wednesday. But what you want to keep in mind is this. Anytime you have components where the top end and the bottom end are tied together, they're in parallel, and they're going to have the same voltage across them. If you have a component where the same current runs through both components or all the components, then they're going to be in series. So we'll combine those, and I'll show you a circuit that I call a combination circuit. Let me pause and see if anybody has any Okay, nobody typed me anything, so let me get rid of this. So this should be a basic review for you all. Now what I want to do is talk about combination circuits. Before I do that, I want to define this term right here, a node. Node. So if you're taking notes, write this down, that a node is a connection of 3 or more wires. A node is a connection of 3 or more wires. So if I have something that looks like this, maybe I have, let's say I have a battery, and I have a resistor, and I have another resistor. So I got these two resistors. If I put a circle around here like this, that circle is cut in 3 places. It's cut right here, it's cut right here, and it's cut right here. It's cut in 3 places. So a node, if you circle a node, is a connection of 3 or more wires. 3 or more wires. So there's actually a node right here, and there's also a node at the bottom. So if I circle this, that circle is cut right here, it's cut right here, and right here. So that defines a node. And I just lost my lights. Can you guys still see? Okay, hold on a second. A technical difficulty. Gotta unwire myself. Okay, you guys couldn't see that, but I had to climb up on the stool and try to adjust the motion detector. So hopefully that doesn't happen again. We'll see what happens. Let me get these wires together so I don't trip over them. Okay, so this idea of a node is important when we get to more complex circuits. So here's what's going to end up happening. Let's say I have, I got something like this. I'm just going to show part of the circuit. So let's say I got something like this. I can connect these resistors like that. And if I circle this, and this part right here defines a node because it cuts 1, 2, cuts the circle in 3 places. And this defines a node because it does the same thing. I'm just shading it in so you can see it better. So what I can do is I can name this top one node A. I'll call the bottom one node B. And if the resistors are R1 and R2, basically anytime I have resistors in parallel, I'm going to end up with nodes. And so what you can do, if I have the voltage between here, like I can talk about the voltage V1, that's the voltage across R1. I can talk about the voltage V2, that's the voltage across R2. And since these are in parallel, they're equal. Parallel resistors have the same voltage. But rather than call them V1 and V2, if I wanted to, I can name that voltage after the node. If I call this node A and node B, I can call this VAB. No voltage AB. So you only have a no voltage or nodes when you have things in parallel. So you want to remember that. Now what I can do with this, if I wanted to, I can do this. I can take these two resistors, and instead of connecting the top with these wires like that, I can connect them like this. So I still got R1 and R2, but I got a connection right here and a connection right here. So if I circle this, now this is node A and this is node B. These two circuits are exactly the same. They're exactly the same. Electrically, they're exactly the same. The difference is we say that the nodes on the left are expanded, the nodes on the right are collapsed. So I have expanded nodes and collapsed nodes. But electrically, they're the same. If you hook this up in lab and you join these two resistors by jumping wires from the top of one to the top of the other, and from the bottom of one to the bottom of the other, it's no difference between doing that and just taking the two wires and just twist them together. You get the same circuit, the same resistance. So when we have complex circuits or combination circuits, we'll end up with a picture like this, and we'll end up combining things, and we'll end up with nodes that are collapsed like this. So I want to give you an example of what I mean. So if you're taking notes, this is where you want to start taking some really good notes, because this is the new stuff, the series parallel stuff. So I have a handout. I may have passed this out in class. I don't know if I did or I didn't, but it's okay. I'll post it on Blackboard when I'm done. But here's a combination circuit. Here's what I mean by a combination circuit. So you got something like this. Actually, I'm going to need more boards, so let me see. We'll come over this way. Hopefully you guys can still see this. All right, so say you have something like this. Now this is a pretty simple circuit, so don't let the fact that it's simple fool you into think that this can't get kind of tricky. It can get kind of tricky, as you'll see probably next time we get together. I'll give you some circuits where it's clear here that these two resistors are in parallel, and the parallel combination of these two resistors are in series with the one here. But sometimes it's not so clear. So some of the stuff that I told you before about series circuits having like one current, parallel circuits having one voltage, that'll help you to see and to understand what's in series with what and what's in parallel with what. So here's a circuit, and some values are, this is 2 ohms. This is 6 ohms. And this is 3 ohms. So given something like this is 36. Given something like this, how would you solve it? Well, here's what you do. What you want to do is start from the part of the circuit further from the voltage source. In this case, the voltage source is on the left, so I'm going to start my analysis on the right. If my voltage source is on the right, I will start my analysis on the left. If my voltage source was in the middle, doesn't matter, I basically would toss a coin, I can start anywhere. But in this circuit, my voltage source is on the left. So what I'm going to do is I'm going to start on the right. And what I want to do here is identify any nodes. You're going to get one color. If you have your coloring pencil, take one color, and you're going to basically circle the nodes. So I got a node here. And what I usually do is just put a box around the nodes like this. So I'll put a box around this node. I like to shade it in. I'll put a box around this node. Now remember, nodes only happen when I have things in parallel. So I'm going to name this one node A. I'm going to name this one node B. So that's the first step. And the work that you guys do for me that relates to this stuff, I want it done exactly like I'm showing you here. You should have coloring pens or pencils. You should use certain colors for nodes, certain colors for current, certain colors for voltage drops, and so forth. Once you do this, the goal is to combine things. You'll have things either in series or parallel. You want to combine things so that you end up with, in the end, just a simple series circuit. Once we get that series circuit, what we'll do is we'll solve the series circuit, and we'll use information from the series circuit to solve the original circuit. Often you have to draw more than one circuit. You might have to draw 2, 3, 4, sometimes even 5 circuits as you combine things. And you'll see as we go through more and more complicated circuits. Let's see how much time I have. Okay, great. Okay, so what I'm going to do here is combine. Obviously, I can combine these two, R2 and R3. So I'm going to redraw this. Matter of fact, the method I'm using is called the method of redrawing. I'm going to redraw this like this. And I'm going to call this is still R1. But this one right here, when things are in parallel, you can have R1 in parallel with R2. I can show it like that. So that means they're in parallel. So I'm just going to call this is R2, R3. So this is R2 parallel R3. So this is what we call an equivalent resistance. So if you write this down, I'll give you a second to calculate what this is. We use these numbers 6 and 3 a lot, so you probably already know what it is. But go ahead and figure out the value of these two in parallel. How would you do that? How would you figure out the two? If I have two resistors in parallel, how would you figure out the total resistance? I'll give you a second. But while you're doing that, I want to make sure all my information from here is transferred to the equivalent circuit. So I still got my 2 right here. I should have called this either VT or VS. I'll call it VS. So I still got VS over here. So we can use the product over the sum rule here if we wanted to. It says R1 times R2 over R1 plus R2 will give me the total. So for this, I got a 6 and a 3. So I got 6 by 3 over 6 plus 3. I got 18 on the top, 9. That gives me 2. So the total resistance here is 2 ohms. 2 ohms. So I want to write that down. And then the last thing I'm going to do is where are my nodes in this circuit right here? Well, node A is like right here. You can't see it anymore. It disappeared into this corner, but node A is located here, and node B is located here. So I'm just going to put a circle at that corner right there and call it A, so I understand that node A is there, and node B is right here. Now let me just pause for a second. I know you're writing this stuff down. I don't want to go too fast. But let me just pause for a second and give you a chance to write this down. Now, once you get to this point, everybody can solve this circuit. That's pretty simple. Everybody can solve it. So, how do you solve a series circuit? Well, we said first thing you do is find your total resistance. Well, clearly the total resistance here, I just add these up. I get 4 ohms. And then we said we use the total resistance to find the total current. Well, that's just Ohm's law. So my total current, I'll take my total total voltage over my total resistance. Total resistance is 4. Now, what you could do here to get the voltage drop, since these resistors are the same, what do you know? These resistors are the same, so really what's going to happen, that voltage is going to be divided in half. It's going to be divided by 2. So even without doing this calculation, you know that across this resistor, I'm going to have half of that because they're both 2 ohms. So I got 18 volts here. And since that's the same, I got 18 volts here. Like that. If you didn't know that, though, you would just go ahead and you solve for your current. So I got 9 amps for current. So notice that I show my current as an arrow. And I'll box it in so that it's current. But what you want to do right away when you get that current is go back to the original circuit and show the series circuit current as the current coming out of the battery in the original circuit. So right away, I'm going to put that 9 amps over here. So whatever current I get in this circuit, whatever I get here, I'm going to write that coming out of the battery over here right away. And now what I'm going to do is just start moving this information from here over to there, and then I'll look over there and see what's missing, what I don't have solved. But by then I should have enough information to solve whatever it is I'm looking for. So what I'm saying is I know that R1 has 18 volts across it. So I'm going to go ahead and show that over here. Across this one. Now this one, be careful. This 18 volts right here is actually pointing, let me draw it, pointing between node A and node B. That's important that you realize that, because remember, anytime I have nodes, I can only get nodes when I have things in parallel. And if I have things in parallel, that means they have the same voltage. So this 2 right here, this 2 ohm, came from the parallel combination of R2 and R3. And since over here I'm showing 18 volts from node A to node B, I have to show the 18 volts in this diagram in a way that shows it across both resistors. So I'm gonna carefully draw it right in between both resistors like this. I'm going to show arrows going from node A to node B, indicating that no matter where I am, as long as these 2 green boxes, these nodes, I have 18 volts. Both the 6 ohm and the 3 ohm have 18 volts across them. So at this point, once I found my current, once I found my voltage drops for each resistor, I'm finished with the series circuit. I'll move over to the next circuit. And this happens to be the original circuit. And I look at this and see what I'm missing. And I notice the only thing I'm missing is the branch current in this resistor and the branch current in that resistor. But what I know is I got the voltage across this resistor. I got the value of this resistor, so I can find the current in this resistor, and I can do the same thing for both R2 and R3. So I'll pause for a second. You go ahead and you figure out what the current is here and what the current is here. And then I'll give another example on the board, and what I want you to do, we'll have a few minutes. I want you to try to solve it. So go ahead and figure out R2, R3. I'll give you a second on your paper. And then I'll put a circuit on the board for you to solve. And I don't know, but we should be able to get through it. If not, then we'll pick up next time with this. So you're solving for I2, this one. And I3, this one. And the way you would do that, to find current is just voltage. I see I have 18 volts across this resistor divided by the resistance. So 18 divided by 6. I get 3 amps here. I'll box that in. And at this point, you can either do the same thing here. I can say 18 on 3. Or I notice that I have 9 amps going into the node A. I have 3 amps leaving node A. And I know Kirchhoff's, one of the rules for parallel is Kirchhoff's current law. The currents have to add up. The branch currents have to add up to the total current. So if I have 3 amps in this resistor, If I have 9 amps going into node A, 3 amps leaving node A, then this has to be 6 amps. So at this point, I will consider the circuit solved. The only thing I can ask for on the exam, the only thing I can ask for that I'm not showing you here will be power. But if you know this, if you know the voltage across the resistor and you know the current through it, then the power would be just V times I for each of these. V times I, you can give me power. So it should be pretty simple. So what I want you to do now, you might have any questions you want to, before I want to put one on the board, I want you to write it down and just try to solve it, and we'll just work through it in the next few minutes that we have left. So I'll give you just a second. Hopefully you got this. By the way, I'm going to post this somewhere on Blackboard, this video, if you want to rewatch it. It'll be on Blackboard or either YouTube. I just got to figure out how to do that. And I'll tell you where it's located. And that'll be true for all the class lectures. We'll just post them all on Blackboard. Okay, so if you got a sheet of paper, copy this circuit down. And this will be the one that, if we don't finish it today, which I think we probably will finish it. If we don't, then we'll pick up with it next time. So copy this down. Okay, so here's the circuit. Here's the circuit. Here's the values. I think what you want to do is identify the nodes, draw the equivalent series circuit, go through the method I just showed you, and then see what kind of answers you get. Then we'll work backwards and we'll compare answers. So I'm going to give you a few minutes to do it, and then I'll start to work it over here in just a second. So you go ahead, identify your nodes, get down to your series circuit, do your calculations, and then that'll be it. Okay, so if you're working on this, what you should have done is take a certain color marker. I got my nodes here I want to identify. Shade it in. Shade this one in. I'm going to call this one A and B. And I'm going to draw my equivalent circuit, which is a series circuit. Now, if I had a more complex circuit, I might have to draw 2, 3, or maybe even 4 circuits. But for this, I can do it with just one. So I'm going to draw my equivalent circuit. Now, if you did the math on this, if you take 12 and parallel with 4, you end up with 3. So this is an equivalent resistance of R2 in parallel with R4. So you use product over the sum, R times R over R plus R, and you'll end up with 3 if you do that. So here's your equivalent circuit. I'm just going to get rid of that for room. Here's your equivalent circuit. And so now what you want to do is move your node information over. So I know node A is here. Node B is here. So you want to solve the series circuit. You should have solved that. I'll give you a second to solve it if you didn't do it already. I came up with a total resistance of 9, add them up, and we have 108 volts. And if I divide 108 by the 9, I end up with current of 12 amps. So I got 12 amps leaving the battery. 12 amps. So then what you want to do is show that 12 amps as the main line current in this circuit coming out of the battery. I have 12 amps. Now on this circuit, I have that resistor at the bottom, and hopefully from the symmetry of the circuit, you can see that if I have 12 amps leaving the battery going through R1, it's going to split up over here, but it's got to come back together and go back through R3 that way. So the point is, if I know that I have 12 amps on the top going this way, automatically I know I got 12 amps on the bottom going that way. So by doing this, I've actually found the current in both R1 and R3. I found both those currents. I got about 3 minutes according to this clock on the computer, so we'll just do this real quick. I can easily get my voltage drops here, 3 times O. So this will be 36. And I notice that all my resistors are the same, so that means each one of these is going to get 36 volts. And over here I get 36. I got to be careful with this one. This 36, it's a node voltage. So I got to show it like this. And then I got 36 on the bottom here. So this circuit is completely solved. The only thing that's unsolved, I notice I'm missing current for this resistor, this resistor. I know the voltage across each resistor. I know the value of each resistor. I'll give you just a second. I think I got about 2 minutes. I don't know if this will shut down or how it works, but go ahead and find those currents real quick, and then we'll call it a class. And while you're doing that, I'll post some information on how we're going to handle the lab and how we're going to handle the rest of the class, the week, the exam, and all that stuff. And then I'm available here for you guys. So real quick, I got 36, I got 12. So this is 3 amps. I can do the same here if I want to, or if I got 12 amps flowing into here, I'm leaving 12 amps flowing into here, 3 going through R2, then they got to add up to 12. So this has to be 9 amps, and I'm solved. The only thing here that I could ask for, that I'm not showing, would be power dissipation, and voltage for each resistor, the current for each resistor. You can easily find the power dissipation. So this is it. That's it. Anybody have any questions you want to shoot at me real quick before this thing? I got like 1 minute. I am going to put this on YouTube, and I will be available during my normal office hours. But we'll see how. Hopefully this gets better. This is my first time being on camera trying to work this way. But I think I can get used to it. And I'm sure since you guys are in the luxury and comfort of your own home, you should be okay too. So if you have any questions, you can email or text me. You guys have a great rest of the day. And I'll see you Wednesday, same time, same channel. That's it. Have a good day.